There are many different sports and many types of athletes. I like endurance sports, in particular running and orienteering. What do you like? In this video, I will briefly introduce you to 5 different types of athletes that are being considered in sport, nutrition and exercise sciences. At the same time, I will also give some examples of nutritional strategies for these athletes. The ultimate goal of an athlete is to perform. Performance is complex and many factors contribute to success in sports, including psychological factors like commitment, drive, tolerating pain, but also tactics, skills and external conditions. Factors like strength, power, speed and endurance have a physiological and biochemical basis, which at least partly underpins performance. It is these physiological and biochemical aspects I would like to focus on, and in particular, the energy metabolism. Our body has 3 different energy systems. First, the so-called phosphagen system, which is immediately available. Second, the short-term anaerobic energy system. Anaerobic means without the use of oxygen. And third, the long-term aerobic or oxidative energy system. For now, it's enough to remember the names of the 3 systems. I'll explain another time how they exactly work. From this perspective, 5 types of athletes can be distinguished: the weightlifter, the sprinter, the middle distance athlete, the endurance athlete, and the game player. Let's meet the athletes. The weightlifter is an example of what you could call an explosive power athlete. Performance takes place in only 1 to a few seconds. Performance for these types of athletes depends on strength and the ability to produce force in a short time period. Other examples are shot put or javelin, but also other sports require moments of explosive power, like kicking a ball. Muscle mass and size are important predictors of performance. A nutritional strategy for this type of athletes is protein intake. This is because protein can help the increase of muscle mass and function throughout training. Energy metabolism is not a major issue for performance, as enough energy is available in muscle via the immediate phosphagen system and regarding the short duration of the exercise. A sprinter also has to deliver a lot of power, but in general over a longer period, so from a few seconds up to 20 seconds. Muscle mass and size are also important for these athletes, although too much muscle mass can limit acceleration. As exercise duration is longer than for the explosive power sports, rapid delivery of energy to the working muscle is another crucial factor. The immediate phosphagen system will supply most of the energy, in particular via a compound called phosphocreatine. Phosphocreatine is present in muscle, but can only provide energy for up to 20 seconds of exercise. With the longer sprints, so more than 20 seconds, also the anaerobic system contributes. The long-term aerobic system plays to only a limited role during sprinting. What about nutrition? Next to protein intake to support muscle mass, increasing phosphocreatine stores in muscle via supplementation of creatine could be a smart nutritional strategy for these athletes. The middle distance athlete is active in intense exercise of a few minutes duration. Think of rowing, track cycling, skating, running on a track, but also combat sports such as judo and wrestling have an exercise duration of 3 to 5 minutes. Typical of these activities is that the amount of work exceeds the energy stored in phosphocreatine, which is limited to 20 seconds of high-intensity exercise. At the same time, the energy cost can also not be met by the long-term aerobic system, as the intensity is too high for this system. So, energy is typically derived from the short-term anaerobic system. However, and as you may know, this system will limit itself due to the accumulation of lactate and its acidification, explaining why an athlete can continue at such a high exercise intensity for, let's say, 8 to 10 minutes. Intensity has to go down. Any idea how nutrition could help these athletes. Optimizing energy stores via the diet is important, but the middle distance athlete can maybe also benefit from increasing the buffer capacity of the body by ingesting of supplements to tolerate the acidification. The endurance athlete heavily relies on the long-term aerobic system. From a biochemical perspective, all exercise with a duration of more than 2 minutes is mainly aerobic. But in general, exercise of at least 10 to 15 minutes, up to multiple hours, is considered endurance exercise. Most iconic probably is the marathon, which is 42 kilometers or 26 miles. If the fastest man can run in close to 2 hours, amazing, isn't it? Next to the biochemical qualities of the muscle tissue, the ability of the cardiovascular and respiratory systems to deliver oxygen and nutrients to the muscle plays an important role in fatigue and performance. Nutritional strategies for these athletes mainly focus on supplying enough energy, either by optimizing stores before exercise or providing energy during exercise, in particular carbohydrates. The final athlete is the game player. Soccer is worldwide the biggest team game sport, but you also have football, field and ice hockey, as well as racket sports like tennis, as examples of a game sport. Characteristic of these sports are the multiple sprints, with limited recovery, combined with the long overall duration of the game. This challenges all energy systems of the body, the long-term aerobic system, combined with the immediate short-term energy systems to fuel the sprints. Fatigue is linked to the depletion of energy stores, and you typically see that at the end of a soccer game, most goal points are made, as all players start to fatigue and more mistakes are made. On the other side, overall performance is much more complex in game sports than in individual athletes, with other factors like tactics playing a more prominent role. So a nutritional focus is harder to define in this type of sports. Energy, as well as protein to support muscle mass, or even phosphocreatine is relevant. And this also depends on, for example, the position or role a player has in the team. In summary, you have learned, very briefly, the typical characteristics of the different types of athletes we'd like to consider in sport nutrition and exercise sciences. The weightlifter, the sprinter, the middle distance athlete, the endurance athlete, and the game player. How would you characterize your favorite sport?